you ever wondered how the lipstick we wear every day stays to be safe? Or how scientists make sure your makeup doesn't contain harmful chemicals? Well, it all comes down to a powerful chemical technique called chromatography. Welcome to our video presentation for CHM256. Today, we are excited to share a topic that might seem hidden behind your favorite beauty products, but is actually very important in making sure they are safe, effective, and high quality. We will be exploring chromatography in cosmetics industry. Before we get into the details, let's introduce ourselves. I'm Sharifah Ainin Sofia Binti Nizam, and I'll be your main presenter and editor for this video. Alongside me are my teammates, Amira Balkis binti Rohazmi and Nur Akila binti Muhammad Daniel Sim. Together, we have worked on this topic to explain how chromatography is used in cosmetics, especially products like lipstick, foundation, and skincare. Here's an overview of what we will cover in this presentation. Now, let's begin by understanding the basics. What is chromatography? Chromatography is a crucial technique in chemical analysis to separate solution elements for analyzing their chemical characteristics. The principle of the chromatography method is the difference in how a mixture's constituents are distributed between a stationary phase to a mobile phase. Based on their different affinities for the two phases, the constituent part of the mixture are separated as the mobile phase passes through the stationary phase. Specifically, the stronger affinities for the stationary phase will cause components to travel more slowly, whereas the stronger affinities for the mobile phase will cause components to move faster. Now that we have introduced what chromatography is, let's talk about why it's important, especially in the cosmetics industry. Chromatography plays a critical role in ensuring that the products we apply to our skin, lips, and eyes are safe and pure. First, it helps scientists identify and measure the chemical components in cosmetic products. This means any harmful substance like banned dyes or toxic metals can be detected before the product reaches consumers. Next, it helps companies meet regulatory standards. Cosmetic brands must follow strict guidelines set by health authorities, and chromatography helps them prove that their products comply with those rules. Lastly, it addresses consumer concern. In a world where people are more aware and conscious about what they put on their bodies, chromatography gives both brand and buyers peace of mind by verifying what's actually inside each product.
Now, let's move on to the relevant type of chromatography that related to our syllabus, which are paper chromatography and thin layer chromatography or TLC. Paper chromatography uses filter paper as the stationary phase. The solvent moves up the paper through capillary action, carrying the mixture with it. The components separate based on how strongly they interact with the water trapped in the paper and the solvent. It is simple and useful for separating color pigments such as in food coloring or ink. Thin layer chromatography uses a solid surface like silica gel coated on a glass plate. It separates compounds based on their interaction to the stationary phase. TLC is more accurate and widely used in food, pesticide, and cosmetic analysis. Now, let's compare TLC and paper chromatography in terms of a few important criteria. For the stationary phase, TLC uses silica gel or alumina, which is a solid surface. Meanwhile, paper chromatography uses cellulose fiber, where water trapped in the paper acts as the stationary phase. Both methods usually use an organic solvent as the mobile phase. In terms of speed, TLC is faster. The solvent travels quicker and gives better separation. However, this comes with a trade-off in complexity. TLC is more complex to set up and requires more precise technique, whereas paper chromatography is simple and more suitable for basic separation. These differences makes TLC more suitable for industrial or research purpose, while paper chromatography is more commonly used in educational settings or simple lab tests. Now, let's look at the principle behind chromatography. The separation process is based on the principle of partition chromatography. This means the components of a mixture separate due to their different solubilities and interaction with the two phases. The stationary phase here is the water that's naturally absorbed in the paper fibers, while the mobile phase is the solvent that moves upward. As the solvent travels, it carries the mixture with it. Components with stronger affinity to the mobile phase will move further, while those attracted to the stationary phase will stay behind. As you can see in diagram, The different pigments separate into blue, purple, and red based on how far they travel from the origin line. For thin layer chromatography, the principle is slightly different but based on the same idea, which is separation based on affinity. The TLC plate is prepared with a sample at the bottom. When placed in a solvent, the mobile phase moves up through the plate. Compound with stronger attraction to the stationary phase move slower, while others move faster with the solvent. As a result, the mixture separates into individual spots on the TLC plates. These spots can be identified using UV light or iodine vapor depending on the chemical properties. TLC is especially useful in cosmetics to check for purity or detect unwanted substances in products like creams, lipsticks, and perfume.
For the real example in cosmetics that used in layer chromatography, some of the products involve are lipstick and foundation. But in this video, I will focus only on how TLC is used to analyze lipstick. So based on the paper written by Bawana Joshi, the purpose of this experiment are to separate and identify the components in the cosmetic product, which in this case is lipstick. Second, to check the purity of the product. So here's how the experiment was done. First, a few lipstick samples were collected, some from local brands and some from branded ones. Then they took a piece of cotton cloth. It was washed, dried and cut into smaller pieces. The lipstick was smeared onto the cloth, and off lights watching it to test the color. Next, they used an extracting solution to pull the lipstick stains off the cloth and into a liquid form. Once the sample was ready, a TLC plate was prepared. A straight line was drawn near the bottom of the plate using a pencil. Then the sample was potted along that line using a capillary tube. After that, the TLC plate was placed inside a jar that contained a small amount of mobile phase, just about 0.5 cm. The solvent slowly moved up the plate, carrying the lipstick components along the plate. They waited for about 5 to 10 minutes until the solvent nearly reached the top. Then the plate was taken out and left to dry. As the plate dried, spots started to appear, each spot representing the different components in the lipstick. Finally, they measured the RF value by dividing the distance traveled by each component with the distance traveled by the solvent. So once everything was done, here's what the result looked like. On the left, we have the TLC result for local lipstick, and on the right is for branded lipstick. If you notice, the local lipstick has more spot and more variation, which might mean it contains more components or possibly more impurities. Meanwhile, the branded lipstick has fewer and more consistent spots, which suggest a simpler and more controlled formulation, probably using higher quality ingredients. This shows how TLC can be a simple but powerful way to compare the composition and quality of different cosmetic products. And one last thing about that pencil we mentioned earlier, that's actually a good reason why pencil is used instead of pen. Pencil lead is made of graphite which doesn't dissolve into solvent of chromatography, so the line stays in place and doesn't interfere with the movement of the samples. If you use a pen instead, the ink would dissolve and affect the results, which would make the whole experiment unreliable. So even something that seems small, like using a pencil, actually plays a big role in making sure the chromatography works properly.
To sum it all up, chromatography is an essential tool for ensuring the safety, quality, and efficiency of cosmetic products, from identifying counterfeit ingredients to ensuring product stability and efficiency over time. Chemical analysis plays a vital role in cosmetics industry. As the demands for cosmetic products continues to grow, manufacturers and regulatory agencies will need to continue investing in the latest analytical techniques and technologies to ensure that cosmetic products remain safe, effective, and innovative for consumers around the world. That brings us to the end of our presentation. Thank you so much for watching. We hope you have learned something valuable about how science keeps our beauty products safe. If you have any question, feel free to ask. Until then, thank you and Assalamualaikum.